page 21. There we go. So this section is called scale diagrams, but I want you to go / scale factors. To be honest, we're going to deal with scale factors a whole lot more than with scale diagrams. I'm just going to zoom in a tad here. Okay. A scale diagram, a drawing in which measurements are proportionally reduced and enlarged by a constant factor. Okay. So we have something that's proportionately reduced or enlarged by a constant factor. From the original, I'll maybe use a different color there. It's right from the original. We're talking about the very original piece that we altered. Right? And notice the wording, folks. There's original / actual. Why are we doing that? I will tell you why I'm using both here. Because sometimes we're making copies of something. Right? We're making replicas. So you have your original item, and you're either making a bigger version of it or a smaller version of it. In that case, I like to use original. But sometimes we have a map, right? There's something on that piece of paper, but then there's the actual distance traveled, right? You can look at it on your little paper. You can measure 3 centimeters on paper, but in actual real life, it's probably 300 kilometers, right? So sometimes it's better to use actual, sometimes it's better to use original, and you'll have to decide when we get there which one you like the most, okay? Scale, a ratio of a measurement of a scale diagram to the corresponding measurement on the original / actual object. Scales can be reduced just like fractions. Different units are okay, but no decimals. Maybe I'll highlight that part. For scales, highlight that part. Different units are okay, but no decimals. So we don't want decimals in there. Scale factor, I'm going to use a different color for that one. I'm going to go orange. Scale factor, the letter we use for a scale factor is K. It is similar to scale, but is expressed as a fraction, decimal, or percent. Okay? It can be expressed as a fraction, decimal, or percent, but this is the big caveat there. A scale factor does not have units. They cancel out. Okay? Okay, so here we have scale and scale factor. So when it comes to scale, you usually will have two numbers. One will pertain to the diagram, and the other number on the right side of the colon will be actual. Okay, so that's one way of looking at it. And this is when you're looking at pictures, blueprints, model, anything like that. I would use the wording diagram actual, okay? And here's the scale factor version. So this is usually two numbers, and they may have different units, folks. They may have different units. When you come to scale factor, K, we write it like this. It's almost like you translate this, and you turn it into a fraction. And you put the first number up top, and the actual, that number would go in the denominator. Okay? So, no units. So I'll put that next to this here. I'll say one more time, remember, no units when it comes to scale factor. So Mrs. Dirksen, are you saying that if I see a scale like this, I can just put this number up top here and this number at the bottom and I'm good? Yes, but you might have to do some converting to get rid of the units, to cancel them out. What is that? Anyways, if you're making copies, replicas, similar objects, we use the wording, instead of diagram actual, folks, I use new original. So I don't want you to think, oh, this is something different. We're different when it's new original. No, we're still doing the same thing. We're treating it the same way, but we're using different terminology. And so the scale factor would be new over original. You know what? I would, on my study sheet, have both versions on there. Just make it smaller than this, right? Don't use up as much space as I'm doing here, but just remember that. So this is a concept that we're going to use a lot. I'll tell you this, whenever we're doing some sort of calculation, I turn a scale, boom, I turn it into a scale factor as soon as I have the chance. Okay, if I have this, I'll turn it into this. Okay. Scale factor, reduction or enlargement, what's happening here? Okay. So remember that the scale factor affects the actual / original, which results in the diagram or the new. Okay. So when you look at the scale or scale factor, it will tell you what happened to the actual or original. This is worth highlighting. So if you have the actual or the original object, right, and a scale factor that is less than 1 is being applied, I will also say this, K would be less than 100%. Here, K is exactly equal to 100%. Here, K is greater than 100%. So bigger than 1 or bigger than 100% is saying the exact same thing. And I'm going to break this down like this. I'm going to section it off like that. So if you calculate K and it's less than 1 or 100, obviously there's a reduction of original. Okay. So examples could be you do some math or calculation, K is equal to 0.2, or K is equal to 2/3, that is less than 1. Because that's 0.6 repeated, right? Or K is 65%, let's say. All of those would indicate, because you will not always have a picture. So if you don't have a picture, it's like what happened to the original? Well, if K is less than 1, you know it's a reduction. If K is equal to 1 or 100, there is no change. You're actually just making the exact same copy, okay? Identical. Identical to the original. And then if K is greater than 1, you have an enlargement, okay? And I'm going to sneak in the actual as well. Enlargement of the original actual. So some examples here would be K equaling 1.2. K is equal to 5/4, because that's actually bigger than 1. K is equal to 120%. So remember, one more. So we have, this is our original here, and all of these represent a new version of the original. Okay, so just keep that in mind. I'm wondering if I should do this right here. I think I will. If this original, folks, put down 100%. That is actually, the original would be like our 100% scenario. Put that down. Put the 100% right next to the original or the actual. So if something, if you say, hey, like you made a new version and you figure out that the scale factor is 120, by how much has it been enlarged, percentage-wise? You went from 100 to 120, so enlarged by 20%. Sorry, this is going to be tight, I know that, but it says enlarged by 20% or 20% enlargement. You do whatever, you write whatever makes sense for you. I'll put that in brackets like that. You good? I need to make sure you understand the concept before I dive into the math, right? If you go from 100 to 65, how much of a reduction happened there? How much have you lost? 35, yeah. I always have problems with that. 35, 45, 35. So it's 35% reduction. Make sure, because then when you review this, you will know right away. So it's always based on the 100% starting point. And so when you calculate, it's like, oh, I'm going to subtract 100 minus 65, so there was a 35% reduction. And this one, when it's over 100, it's usually easy to tell right away, right? We know it's like 20% in this case. But it's always with respect to 100%. All right, let's keep going. Let's do some. So this is a lot. There's technical terms. You need to make sure you're aware of what that term is asking you to do. So given the scale 1 centimeter to 50 meters, this is a scale. Different units are okay when it comes to scale. State the scale factor used as a fraction decimal percent. So let's do that. So from 1 centimeter to 50 meters, this is the scale. Okay? We're going to turn that into a scale factor. This into a scale factor. So we put the top number with units and all down, and the bottom number goes here. We can't have different units. We want them to cancel out. So we got to go like this. What do you want to do? Centimeters to meters or meters to centimeters? I tend to go to the smaller unit. That's what I tend to do when I convert. So I'm going to say that 1 meter has a 100 centimeters, like this. Watch what happens here. It's right. This cancels out. This cancels out. So you have 1 times 1 is just 1. 50 times 100, that's 5,000. Now you're in business. Okay, this is what we want. We want no units. Okay, no units. So we are happy. This is technically, if I didn't ask you for a decimal percent, you would be done at this point. I actually say just stop with your fraction. Don't continue unless I ask you to do otherwise. So we can say k is equal to 1 over 5,000. Or grab your calculators. I think this is going to give you a bit of an issue here. This calculator tries to go to scientific notation as soon as possible. So you just go 1 divided by 5,000, you get that. The answer is not 2, okay? You can't just ignore this. So I'll go on the side here, on the top, I will do this. Note, 1 divided by 5,000 is going to be 2e negative 4. This is going to come in back later on as well. That translates to 2 times 10 to the power of negative 4. Okay, that's what that does. That is the equivalent. Write down whatever number it states. I'm going to go over here. The decimal is right there, so you're going to move over 4 spots to the left. 1, 2, 3, 4. That's your decimal right there. And you fill these values that you've created with zeros. Okay? That is really what the answer is as a decimal. And you're like, oh my goodness, so that's why I dropped science, right? You can't drop science. You can do physics or chemistry. But here's my trick for you, okay? You ready? All you do is take whatever number you have with a negative exponent, just add 1 to it. Go ahead, plus 1. You just have to make sure you ignore the one you just added to it, and then it will show you the decimals that follow it. That is my trick for you, but this is the answer here. That is the decimal here, and if you multiply that by 100, the decimal goes over 2 spots, right? So this would be 0.02%. Doesn't happen very often, but it does. Let's see here. If I multiply that by 100, then you have a problem with the 1, right? So you just got to watch out when you convert that you don't worry about. You can actually just do this. 0.0002 times 100 if you're more comfortable, and then that's your percentage, right? So this is the answer for A. Separate them by a comma, and then you have your various. Okay? This is a reduction. Reduction of original. Why is that? K is less than 100%. Way less. It's actually super small. Yeah. Okay. Ready? So B, what is B asking? By how much has the original been reduced? We go like this. 100% minus 0.02%. You subtract it from 100. And you get 99.98%. It has been reduced by 99.98%. Okay. How do we know it's a reduction? Because K is less than 100%. To know by how much, we take the percentage away from 100, and there you go. You could take this away from 1 and just state it as a decimal. You don't have to use percentage, okay? Unless I tell you otherwise. Oops. Saved. Okay, keep going. So I'm giving you some diagrams here to go off of. Okay. So remember, everything is connected here. I'm just using it in different scenarios. A, the scale determined, right? The scale, not scale factor, used to produce the diagram. Okay. So let's do that over here. A, we're talking diagram here. So remember, diagram, that number would always come first. And I'm also using diagram on the diagram, right? I told you, this is diagram, that is actual. And you have to have them in the right order, which is determined by what I gave you on the previous page already. So you need to find corresponding measurements, right? So we're going to say, in this case, we have both of the lengths of both pictures here. So we're going to write that's a length which matches that one. They're corresponding, right? So this would be length and length, okay? So you take the diagram, which is 14 inches, and the actual is 25 feet. And that is actually your answer, because it's a scale. Different units are totally fine there. What's a scale factor? Right? What's the scale factor? That's K. right, to produce the diagram? What scale factor has been used to go from here to here? Well, this is where I answer B right here. K, in this case, is diagram over actual. Like that. You don't have to tell me this in the future. This is just for your notes. So I take the 14 inches and I put it over 25 feet. And I need to do some converting. I'm going to go, my goal is to turn these 25 feet into inches. That's what I'm going to go with. So I know that 1 foot has 12 inches. And notice what happens right there. You can see that everything is going to cancel out. Cancel, 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 cancel. 14 times 1 is just 14. 25 times 12 is 150. Nope, I'm on the wrong page here. 300. 300. And here's where I'm going to show you a nice feature of this calculator. Technically, we want you to reduce fractions, but I don't give any marks for it anymore. The province doesn't give you any marks for reducing. In fact, unless you're asked to reduce, don't reduce ever. Because if you make a mistake in your reduction efforts, you lose marks. So do this with me. 14 over 300. You go 14 divided by 300. You ready for this? It's going to blow your mind. You go math. You press the math button. And there's the first option which turns anything to a fraction. So we're going to go ahead and select enter there. We're going to press enter there. So enter one more time. And it gives you the reduced fraction. If it can, it will always try to reduce it for you. So it's 7 over 150 is the same thing. These are all equivalent fractions there. Does it ask me to give it as a decimal? It doesn't. But I'm going to do this anyways. So 7 over 150, comma. Let's figure out what that is as a decimal. 0.0, I'm going to go 5. If I round that to 2 decimals, that's what you get. And then I'm going to multiply this by 100. As a percentage, this would be 4.66%. Not 5%, 4.66, because it's based on what is on my calculator. I rounded to 2 decimals there. That's the scale factor there in the 3 formats. So what's the difference between a scale and scale factor is you need to get rid of the units. Got it, okay? I'm going to cut that there. C, determine the height of the truck on the diagram. So C is right here. And here's where I'm going to ask you to just use what you know, okay? Determine the height of the truck on the diagram. I'm going to use, you can use this fact right here or the scale factor. It's up to you what you want to use, okay? But I'm going to use this one here and turn it into a fraction. So 14 inches over 25 feet. And I'm going to say, determine the height of the truck on the diagram, right? So that's this one right here. I'm going to go height of diagram. And this is going to be the height of the actual truck, which is 10 feet. Like that. Remember, the top on both sides represents a measurement on the diagram, and both measurements at the bottom here correspond to the actual truck. Just remember that. Okay? So here we go. H is going to be cross multiply and divide. So 10 times 140, sorry, 10 times 14 divided by 25. Your answer is going to be in inches because it's in inches also on that side. And that gives you 5.6 inches. So the height of this truck on the diagram is 5.6 inches, which does make sense. It does add up. Okay? So that's the answer to C. And last but not least, D. By how much has the actual truck been reduced? We know it's a reduction because K is less than 100%. Okay? So we go 100 minus 4.66%, 100% minus that. And that gives me, oh, sorry, did I make a mistake rounding this one? I did make a mistake rounding. 6, 7. I was too busy talking. 6, 7. So please turn this into a 7 here. That would be an R right there. Now this video is a rated R video. Okay. Anyways, 100 minus 4.67. That would give you 95.33%. So it has been reduced by 95.33%. So you went all the way from 100% and reduced it by 95.33% to only be left with this. Okay, so it's actually been quite a reduction there in this sense. Okay. All right. So there's some proportional reasoning, knowing how to state, doing some conversions. All of that is part of this section here. So it's not going anywhere. All right. I'm going to ask you to do the following. 1 second here. 23 to 26 is what I'm going to post. So I'm going to go over to page 23. And just at the top here, I would say 23 to 24 is the bare minimum. It shouldn't take you that long, right? 23 to 24, but if you can do more, go all the way to 26. So I'm going to stop here, and I'm going to look for the key already and post it. So while you work until the bell, oops, sorry guys. You go ahead, right? Thank you.